What's happening, everyone? You're back here with Jono for another quick math lesson. Today we're going to be looking at the difference of two squares. So really this is just a special type of expanding a binomial product and the factorization that goes along with it. So we've got something like this. We've got x plus 3, x minus 3, both in brackets. And we can solve this quite easily using either FOIL, which we did a couple of lessons ago, or with the shortcut. I'm going to do it with FOIL just to start off. So we take the first two terms, multiply them together. So we've got x squared, x multiplied by minus 3 is minus 3x, 3 multiplied by x is plus 3x, and then 3 multiplied by minus 3 is minus 9. When we collect these like terms, we can see that the two middle numbers, minus 3x and plus 3x, equal nothing. They cancel each other out completely. So all we're left with is x squared minus 9. If you do prefer using the shortcut, you could have seen straight away that with this, I'll just write it again, with x plus 3, x minus 3, we know that the last number has to be the product of the two numbers. So plus 3 and minus 3 equal that minus 9. And the middle term has to be the addition of these two, which again is 0. So either way you do it, you're left with, instead of a trinomial, you're only left with two things. We'll see a couple more examples. So on this one, x plus 4, x minus 4, if we go straight to the answer, we can see that this is x squared, nothing's in the middle, and then minus 16. We can fully FOIL it out, but you'll have plus 4x and minus 4x in the middle, which cancel out. And this can happen the other way as well. We're going to FOIL this one because it might be a little bit easier to see. But even if our number's the first term, this kind of pattern still works. So for this one, we've got 6 times 6, which is 36. 6 times y, which is plus 6y, minus 6y, and then minus y squared. So our answer for this one is 36 minus y squared. And that is our final answer for these ones. So the rule for these types of binomial expansions is that x plus some number a multiplied by x minus some number a, so the same thing, straight away equals x squared minus a squared. While this doesn't seem like a huge shortcut, it becomes really important in other areas of maths. Anything with parabolas and nonlinear relationships, and even circles, this kind of maths will pop back up. So it's a really good thing to know. We also know that once we've expanded something like this, we can factorize it and put it back into these brackets no matter what. And this basically is factorization. So going from that rule, we're trying to turn the answer from the last one back into the brackets. The most important skill for knowing how to do this is if you know your square numbers from like 1 to 144, you're going to find it much easier. So our square numbers are 1 times 1 is 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. You might need to know some higher than that as well, but if you've got these base kind of 12 or like your times tables, it's going to make this way easier, I promise. So for this one here, we've got x squared minus 25. So instead of squaring like we did in the last example, we're going to square root our pronumeral. So x squared is going to be square rooted. We're also going to square root the other term. Just make sure that in your calculator, you don't include that negative. If you put a negative under the square root sign, it's going to give you a math error. So just put in the square root and hope that it works, and it'll work out for you. So the square root of x squared is just x. And we're going to have that in the bracket plus the square root of that second number, which is 5. Then we're going to have the exact same thing, x, but instead of plus 5, we have to minus the 5. So this is turning this difference of two squares into two brackets. This can even happen when we've got a non-monic x squared. So this time we've got to square root both of our terms. The square root of 4x squared is 2x. So that's going to be our first term, plus the square root of 81 is 9. Then we've got to have the exact same thing, except with a negative in between the two terms. So this is going to be 2x minus 9. If we FOIL that out, we are going to get the same number, so we know we've got it right. Even if our terms first and our pronumeral second, we can still do it. The square root of both of these will have 12 plus x and 12 minus x. So this isn't too difficult if you can see those square roots straight away. The perfect squares make the maths quite easy, as long as you've got the same thing written twice, but just with a different operation in the middle, you know you're going to be correct. We can actually also do this if the number at the end is not a square number. And it's kind of like annoying to do, but if you squint, you can see that it is still a square. So we know the square root of the x squared is x, so I'm going to put that down with my brackets straight away. And now obviously 5's not a square number, but the square root of 5 squared is equal to 5. So I know that that's a little bit annoying, but these two cancel each other out. So what we can say here is that the square root plus the square root of 5 and minus the square root of 5 are going to give us that correct answer. If you guys haven't done surds yet, this might be a little bit difficult, but it is a topic of mathematics that will be really important moving into senior years. We can also do this if the whole first term is squared in brackets. So for this one, we've got x plus 4 squared. That's our square term. So here, instead of just writing our x like we did in the last one, we're going to write x plus 4 twice, because that is squared in both terms. Then this time we've got to do the exact same thing that we just did before. We've got square root negative 11, so we've got plus root 11 and minus root 11. So again, we've got the exact same brackets, just with one different operator. I hope this made sense, and I'll see you soon. Thanks so much for watching, guys. Congratulations on taking some time to get better at this algebra. I know it can be a little bit difficult sometimes. If you do need some extra work, remember there are some free worksheets linked in the description below, as well as some notes that came from this video, so you don't have to pause it and scribble them down. If you do get a second, please like and subscribe to the channel, because there'll be new maths videos coming out every couple of days. Thanks so much. Have a good one.